Welcome dear students. This lecture is about the Lewis structures and resonance forms of the sulfur dioxide. Dear students, to write down the Lewis structure, first of all the number of valence electrons are calculated. Sulfur and oxygen both are members of the group 6A. If they are members of group 6A, it means they have 6 valence electrons. One atom of sulfur has 6 valence electron. Similarly, one atom of oxygen also has 6 valence electrons and 2 will be having 12. So the total number of valence electrons in sulfur, they will be sulfur dioxide, that will be 18 valence electrons. After calculating the number of valence electrons in a molecule, now you will write down its skeletal formula, including the symbols of the elements in that molecule. And then you will join the atoms through single bond. After joining the atoms through single bond, now you will complete the octet of the atoms. Single bond means there are two bonding electrons here. So this oxygen has two electrons in the form of bond pair, and to complete its octet, it must have 6 more electrons in the form of 3 lone pairs. And thus 1, 2, 3, 4, 5, 6, 7, 8, its octet will be completed. Similarly, this oxygen has 2 electrons in its valence shell in the form of one bond pair. So in order to complete its octet, it must have 6 electrons in the form of the 3 lone pairs. Now octet of both these oxygens is completed. If octet of this oxygen is completed, it means it has 8 electrons in its valence shell. So this oxygen having 8 electrons in valence shell. Similarly, this oxygen is also having 8 electrons. So 8 electrons plus 8 electrons, it means total 16 out of 18 valence electrons are used to complete the octet of the two oxygen atoms. Now there are remaining only 2 electrons that will be given to sulfur in the form of one lone pair. Now let us see whether the octet of sulfur is complete or incomplete. Now sulfur is having 1, 2, 3, 4, 5 and 6 electrons. It means by using these 18 electrons, the octet of both oxygens is completed, but the octet of the sulfur is still incomplete. So now what will happen? Uh, this oxygen will share its lone pair with the sulfur, and single bond will be changed to the double bond. It will be sulfur, double bond oxygen, and this oxygen will be having a single bond. Now, the sulfur has already a lone pair of electrons, and now there are two bond pair of the electrons here, and there is one bond pair of electron, and this oxygen will be having 3 lone pair of the electrons, as none of its lone pair is used in bonding. But this oxygen was having 3 lone pairs. One lone pair is used to make a bond between sulfur and oxygen, and there will be remaining 2 lone pair of electrons on that oxygen. So this one is first structure of the SO2. Now, in first case, this oxygen has contributed its lone pair to convert the single bond into the double bond, but there are equal chances that it is quite possible that instead of this oxygen takes part and shares its lone pair of the electron with sulfur to convert single bond into the double bond. So the second possible structure will be sulfur can have double bond with this oxygen and single bond with the other oxygen. And now there will be one lone pair on sulfur. This oxygen will be having 3 lone pair of electrons, and this oxygen will be having 2 lone pair of electrons, and in this way the octet of all atoms is completed. Now this one is the structure 2. Both these structures, dear students, they have equal number of atoms, they have same position of atoms, they have same total number of electrons, that is 18 each, total number of valence electron, but the difference is in the bonding arrangement basically. So these two are called as the resonance structures or canonical structures of each other, and they will be connected by a double-headed arrow, that is the symbol of the resonance. And what will be the actual structure of the SO2? that should be the hybrid of these two resonance form. It should be having a bond that should be stronger than single bond but weaker than a double bond, and the bond order should be 1.5. And this structure, that will be basically resonance hybrid, having lower energy than its canonical forms and higher stability because of the phenomena of the resonance. Now, my dear students, for the easiness, because there are equal chances for both oxygens to share their lone pair of electron and form double bond on both sides. So, in your textbooks, you see that like this, the structure like this is drawn. In that case, dear students, sulfur will be having 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 electrons. So the sulfur will be having 10 valence electrons. That will be an example of the expansion of octet. Just for your easiness, instead of writing the SO2 in this form, you see that the books write down the SO2 in this form. And in this structure, there are double bonds of the sulfur with both oxygen atoms. But in that case, that sulfur will be having more than 8 electrons in its valence shell, and that will be an example of the expansion of octet. While oxygen, both they have two bond pair and two lone pair each, and their octet is completed. So that is the resonance hybrid. These are two canonical forms, the resonance structures of the SO2. And if you will just write the dot structure of the SO2, it will be written something like this. According to this, it will be one lone pair with sulfur, two lone pairs on two oxygens, and four electrons between sulfur and oxygen, which shows presence of the double bond. So that will be the dot structure of the SO2. And this was all about the resonance forms and dot structure of the SO2. Next time we will come up with some new lecture. Till then, take care.